Hello everyone, my name is Jovita and I will present our work Differentiable Architecture Search, a one-shot method, which is joint work with Jonas, Michael and Margret. So far, Differentiable Architecture Search, in short DAS, has mostly been used in classical image classification settings, as for example on Cypher 10, with optimized hyperparameters and well-conditioned search spaces. However, in this paper, we analyze DAS in a new setting for inverse problems, where neither the search space nor the suitable hyperparameters are known a priori, which leads to an extensive analysis of the performance of DAS with different search spaces and operation set. And we find that DAS is indeed able to find well-performing architectures if the search space is well preconditioned. Also, we can see that DAS induces a large variance for several runs and also optimized hyperparameters. And also here we find typical DARTS problems as the rank disorder issue and the poor test generalization. In this paper, we consider inverse problems in which we want to recover x from data y for linear operator, where here our experiments tackle to recover 1D cosine data from varying magnitude, amplitude, and offset, and search for models to recover these samples from different distorted operation measurements as the Gaussian blur or damped sampling. We look into different operations to solve this objective. First, two beneficial operations, a learnable gradient descent layer and a neural network layer, both motivated by the literature. To complement these beneficial layers, we also include two potential harmful operations, a noise layer with white Gaussian noise and a roll layer. We look into two different search spaces, a sequential search space, which is again motivated by the literature, and a wider cell-based search space, which is motivated by the original DARTS formulation. Here we investigate the performance of DAS on the sequential search space and compare it to several baselines. And we can see that DAS performs substantially worse than a random search baseline in the case of having only good operations. However, on the largest search space, which also includes negative operation, DAS performs better. However, this result shows that DAS finds an architecture which is, however, far from the optimal architecture. Here we also plot the found architectures from the previous table, and we can see here the indication of a correlation problem. That better one-shot validation does not imply a better architecture validation after retraining, which is the well-known problem in DARTS, the rank disorder issue. In order to investigate a possible improvement on the rank disorder, we optimize the hyperparameters using BOP on 3 different targets, and we can see that there is no consistent improvement using the optimized hyperparameters, neither for the blur nor for the downsampling distortions. And in fact, we can actually see that the apparent stabilization using optimized hyperparameters removes not only negative, but also positive outliers. We also look into the non-sequential search space, which is motivated by the wider cell-based search space in the original DARTS formulation. And in this table, we can see that this search space does not improve the overall performance, but indeed even hampers the search for all possible approaches, resulting in a lower architecture performance. In conclusion, we can summarize our contributions from 2 different perspectives. From the inverse problem perspective, we provide the first extensive analysis of the performance of DAS for inverse problems, and we have shown that hybrid architectures have the potential to outperform architectures that purely consist of one single operation. In addition, we show that in this application there is little benefit in considering the non-sequential wider search space, which is, in conclusion, a high practical relevance for the design of architectures for inverse problems. On the other hand, from the differentiable architecture search perspective, our findings are already suspected from the community as the rank disorder issue. However, existing literature focuses on well-established search spaces with well-established and known hyperparameters, which results in limited fluctuation of the DAS results. Now, applying DAS to a new, not well-studied setting allows us to observe DAS with less controlled conditions, where neither the search space nor the hyperparameters are given a priori. And lastly, due to our simple and computational manipulable setting, we can make statistical significant observations of the behavior of DAS. This results in the need that thus should be validated in a statistically significant way in general. Thank you for listening.